Okay, so a concept we need to explore is sets. Okay, now sets is quite a broad idea and we use it throughout different aspects of maths, but we're going to really focus on how to use Venn diagrams to explore sets. Okay, so a Venn diagram, which makes it easier, a Venn diagram here will be limited to two sets. That's what we're going to be looking at. We won't go too hectically into it, which we'll leave that for A level or whatever. So what we're going to look at is the number of elements in a set. We're going to look at the complement of a set. We're going to look at a universal set. We're going to look at the union of A and B, the intersection of A and B. And then we'll look at a couple of examples. Okay, so let's start off with the number of elements in a set. Okay, now, or let's actually first explain what is a Venn diagram. Okay, so a Venn diagram is a visual way of representing and understanding a set, which basically, let me show you. So we're going to take a rectangle. And I might have that section there and that section there. Okay. So I might have people who like pineapple on pizza. People who don't. And people who eat pizza. No, okay, that's the lame one. Okay, let's erase that. Can you think of two things that we can, two groups of people? Because now I'm yeah, I love that. That is so simple. Imagine if I could just do simple things like that and just like think through, just not overcomplicating life. So people who like red. Oh, this is the pen function. I don't like the pen one. I like the pencil one. People who like red. People who like blue. And then people who like both. So let's say the red people, the blue people, and the both people. So the red people, let's say, and let's say there's a total as well. Let's say there's a class of 30 students. Okay. Now, 12 people like red, 6 people like blue, and 3 people like both. Okay. So I'm going to put my 3 over there because 3 like both. But now I've only got 6 people who like blue. So I'm going to take my 6 minus 3, which gives me 3 people. 3 people plus 3 people gives me my total of 6. Red is 12 minus 3, which is 9 people like red. And my total is 30. So I've got 9, 10, 11, 12, 13, 14, 15. So then I've got 15 people out here who like neither. Okay? And so that's my basic Venn diagram. So what I'm going to do there is let's look at our different notation here. Let's use orange. Okay. So the number of elements. So if I say an element is how many different things are there? So how many different elements are in this thing? There are 30, right? Okay. So n of A is equal to 30. Well, my number of elements in, I'm going to make this whole thing A. Okay. I'll make this one B. I'll make this one C. So my number of elements in B, which is the red, would be 12. My number of elements in C would be 6. Makes sense? Now, it goes a little bit further because I might want to say, what about not A? Okay, so my number of elements in not A would be what? Let's go look again. So my number of elements in not A, oh, so let's do not B. So everything that's not in B would be this 3 and this 15, right? So my number of elements in not B would be 3 plus 15, which is, okay. So that would be the not A. And this is called my complement. Now, if you do art, you would know that there are complementary colors, right? So complementary colors are like the opposite colors. So the complement, so A, the complement of A is A1 because it's the opposite of A. So everything that is not A. Okay. Now, E sorry, is our universal set. And the way that I created this one was I actually named our universal set A. Okay. This could be D. A universal set is basically something that includes everything. Okay. So now there are two fun ones here. I've got union and intersect. Okay. Now union means that it's in one or it is in the other. It doesn't have to be in both. Just one of them has to have it. But intersect means that both must have it because both are touching it. Make sense? Because the how I used to remember it, I used to think, okay, well, union is like a marriage, and I mean, it might be yours, but in marriage, what's yours is mine, what's mine is yours, and so even though it's yours, you're touching it, I still have relation to it, and so it still counts. Over here, if it's intersecting, we both have to kind of have ownership of it. Okay. So, some examples. We're going to do proper examples just now, but I just want to do some basic examples. So, some ways that we might have a set written as is A is X is an element of, well, X, where X is a natural number. So that's one way of writing it. Now, another way of doing it is another example we might have is like something like B is equal to A, B, C. Or it could be B is equal to 1, 2, 3, 4, so forth. Okay. Then we could also have C where X is A is less than or equal to X, and X is less than or equal to B. So X is greater or equal to A, or X is less than, and X is less than and equal to or equal to B. So it's somewhere in between that. Okay, and this would also be a thing, an example. Okay.